Welcome to the Libertarian Counterpoint. I'm Richard Fields. On the program tonight we have Lee Welter, physician from Sacramento, and we have Tom Tamarkin, the president and CEO of USCL Energy Site. Now, you have several patents, Tom. Tell us a little bit about what you have patents for and what they do.
Well, yes, I do. In fact, I can talk about them because I brought the patents with me, because people often say,
what does a patent look like?
What does a patent look like?
Okay,
so
good.
I, in fact, have 2 issued United States patents, 1 issued Israeli patent, and the big red patent, which is issued in the People's Republic of China, and a 5th patent, which is issued in the European Union throughout the various members, 27 members of the European Union. And these patents relate to the smart meter and the system topology of the smart meter.
The systemology?
System topology.
How things are connected.
How things are connected, if you will. Exactly.
Now, your company is in the business of marketing smart meters, is that correct?
In 2001, in California, as you recall, we had an energy crisis.
Right.
We lobbied the politicians, and we actually manufactured and prototyped what we called in the industry pieces of hardware and pieces of software, and demonstrated this technology, if you will, to politicians in April of 2001 at the height of the California energy crisis. A gentleman who attended that open house of ours was a senator named Tom Torlakson. Tom Torlakson took keen interest in what we were doing, and he and another gentleman at UC Berkeley wrote a bill which directed the California Energy Commission to come together with the California Public Utility Commission and do a 2-year study of what we call pricing elasticity, which is a fancy way of saying variable price structures and how these structures would impact consumers and their use of energy.
So you're talking about variable price based on demand of electricity, say, at various times of the day?
Exactly.
Okay.
What we call peak demand as well as time of use rates. So that, in fact, happened as a result of the technology that we demonstrated to the senator in April of 2001.
That makes a lot of sense. It sounds very wholesome. It's like discounting movie tickets when the theaters would normally be empty, right?
Well, the fact of the matter is that the cost to produce electricity, and let's understand that utility companies are businesses.
Of course.
And there are privately held utility companies like PG&E, which can be listed on the stock exchange, and there can be municipal utilities such as LA, DWP in Los Angeles, and SMUD here in Sacramento, and Palo Alto Electric in Roseville, which are operated by cities. And there is a 3rd type of utility, which is referred to as a rural electric co-op. Collectively, there are approximately 1,500 of these utilities who serve 135 million accounts nationwide. Now, of these utilities, each of these 3 types of utilities have different regulators that they have to serve. And as a result, they have a different mix of how they can pass on their cost to produce electricity to the customer in what we call the regulatory framework. But the bottom line is they are businesses. They produce a product which is generating electricity. They deliver that electricity throughout their service area, and they, like any business, use something. Here's my favorite picture, which is a cash register. And the cash register of the utility industry is what we call a electromechanical power meter. Most people are familiar with something that looks like this on the outside of their home. There are 135 million of these electromechanical power meters throughout the country. And now, over the course of the last 5 years, these old-fashioned electromechanical meters are being changed out with a more modern type of cash register, which is a solid-state electronic power meter, commonly called the smart meter.
Is that what you have patents for?
That is what we have patents on, yes.
Okay, so you're marketing then your smart meters through the utility companies, in effect?
We license the technology through utility companies and manufacturers.
Okay. Now, the whole concept of smart meter is somewhat controversial these days because, for a number of reasons. One reason that I'm aware of is people who are fitted with smart meters thinking that they will be able to save end up paying more. Is there anything to that?
Well, actually, the opposite should be the case because, as I started to say a minute ago, the production of electricity and the cost associated with the production of electricity is a function of the peak demand. So as demand goes up, the cost to produce power goes up. And the formula actually shows the cost increase from the least expensive time to produce power to the most expensive time to produce power as being in the range of 100 to 1.
So a free market would dictate that if it's more costly to produce, the price ought to be higher.
Exactly.
You can't sell below cost and expect to make up on volume, can you?
Well, ideally, you want to pass on the true costs of production at any point in time to the
Yes.
consumer.
Makes
But
sense.
because this formula, as I indicated, has a dynamic range of 100 to 1,
That's
that's
a big
very,
deal.
very difficult to do. And that involves a concept called dynamic pricing, which this smart meter ultimately will allow to be implemented over time.
Okay. Now, is there any reason not to use smart meters? Is there any reason why consumers should resist or be concerned about the use of smart meters if it's going to allow power to be priced more reasonably and ultimately save them money?
Well, as a matter of fact, if we look at the construction of what I refer to as an old-fashioned electromechanical meter, we'll note that there is a spinning disc, and we can think of this spinning disc as an electric motor, and the speed or the rotational velocity of this disc is a function of how much power you're using at any point in time. I won't get too involved in the details of how this meter works, but suffice it to say that it consists of a number of mechanical devices, including some very strong permanent magnets. And these magnets, over a period of time, become weaker. And as these magnetic fields become weaker, it causes the dials to spin faster, which means the customer is actually paying more for electricity over, say, a 10 or 12 or 15-year period of time. It's a subtle creep.
So they
But
would be
it's a fact that utility companies try not to acknowledge.
yeah, but those customers would be better off with a newer, more accurate device, I presume.
Oh, absolutely, because the new devices are electronic, they're solid state, and they are extremely accurate, and they remain accurate for long periods of time. They have no adjustments or calibrations, unlike these old-fashioned
Still,
meters.
there is resistance, political resistance to smart meters. Why is that?
I'm not sure if there's political resistance, but there's certainly consumer resistance.
Okay. Consumer resistance being expressed politically.
However, if I were an executive in one of these power companies and I knew it would cost me money because these new meters would be billing my customers less, I'd probably agitate for them to stick with the old ones, wouldn't I?
Well, again, it's a complex situation because these meters, the new meters allow so many new things to be done, which themselves can be translated into revenue opportunities for the utility company. So it's been quite an educational process, both for consumers as well as the managers of the utility companies.
Well, the new meters get rid of the meter reader, for one thing, right?
Yes, so the person who walks from station to station writing down the
The guy that
reading
visits your
on the
house every
dials.
month to look at the meter.
Well, traditionally in our country, the meters are located outdoors. And meters by law in virtually all 50 states are required to be read, with rare exceptions, once a month.
Yes.
And to the extent that the meter does not communicate electronically with the utility, and of course these old-fashioned meters don't, they have to be read manually by somebody who
But the smart
literally
meter,
walks
yeah,
up and
the
down
smart
the
meter
street.
doesn't need that, right?
Yeah, the smart meter doesn't need that, but the old-fashioned meters
So that's a saving. That's a
required,
labor saving for
manual reads.
that's a labor saving for
So
the utility.
this is a labor savings for the utility.
Okay.
And improved accuracy as well.
But also, there's improved accuracy for the utility as well as for the customer.
Okay. Are there any health risks to any kind, the old-fashioned meters or the newer meters?
Well, as I mentioned a few minutes ago, the old-fashioned meters worked on a theory involving magnetic motors, which means electromotive forces or electromagnetic forces. So the answer to that is there's absolutely no health risks whatsoever. The new meters, and let me, by way of example, show a new meter. This meter is a meter which is being installed throughout the country. It's manufactured by a well-known company called Landis & Gyr, which is probably the largest meter manufacturer in the world. And this meter replaces those old-fashioned electromechanical parts with solid-state electronics. This is the actual circuit board located inside the meter, and this is the actual power measuring device which is located inside the meter, and this consists nothing more than a small transformer, a toroid or a circular donut-shaped transformer, which simply surrounds the wires connecting the power coming from the utility to the circuits inside the home. So when we look at what is inside the smart meter, there's absolutely nothing in this meter that can generate any type of a health risk
So,
from a scientific standpoint. However, from a consumer standpoint, there are a number of groups around the country that have kind of eked out positions that health risks, in fact, do occur because these meters transmit the data to a remote location
That's their
using
claim.
radio waves.
Just like a cell phone, right?
Just like a cell phone or a wireless keyboard or a
Yes.
wireless mouse or a
Yes.
Bluetooth device that you use to actually talk to your cell phone remotely.
Or a
Or
Wi-Fi.
a video game controller or an AT&T UVerse television wireless converter box in your
Yes.
home. so
or a
that you can
cordless
move
phone,
your
or a remote
Ex-
control,
exactly.
or a radio station, or a TV station, or any number of RF devices.
Well, TV stations and radio stations transmit at much, much, much higher levels of power. So theoretically, if there was a danger, that's where the danger would be coming from. But once again, there is no known danger from radio waves. And in fact, I should point out the fact that we are born with a constant exposure to radio waves coming from outer space. We call this the galactic floor. And the galactic floor has a Gaussian distribution or a bell curve distribution of radio frequencies virtually over the entire frequency domain. And as ham radio operators, this is something that we have to put up with because we have this background radiation. If on television in the old days, we called it snow. But we live in the world of radiation.
And we're bombarded regularly with cosmic rays. Very,
Exactly.
very high energy phenomena.
And happily, the Earth has a magnetic field which serves to trap the predominance, the large amount of the cosmic rays that you're talking about. But it is that cosmic radiation that forms this, what I referred to as the galactic floor.
I once heard a presentation of an experiment addressing this concern about the health risks of cosmic radiation. They took some laboratory animals, mice or rats, kept them in cages deep inside a granite mountain where they would be shielded from the cosmic rays. Of course, there was an equivalent number of animals on the outside exposed to the normal level of radiation. The ones exposed to normal radiation levels were healthier than the ones kept alive inside that mountain because they needed that energy to maintain some of their normal cellular mechanisms. It's called hormesis.
Well, of course. And the reason for that, of course, is that all life, mammal life forms on the Earth have evolved over hundreds of millions of years, and they are accustomed to this background radiation.
Exactly.
Okay, so in other words, would it be fair to say that the background radiation that we get from outer space is much larger than any man-made radiation from all of the various devices that we work with, like from microwaves to cell phones to wireless meters?
Well, in order to answer that question in the scientific standpoint or from an engineering standpoint, we have to talk about the magnitude of the signal, and then we get involved in millivolts per square meter or decibels, and I think that becomes far too complex
It
an
is.
answer for
I
this,
agree.
For this audience. There are several issues, though, that we can explain very simply, and most notably, radio signals decay or fall off in what we call an inverse square law. So if I have a device inside the meter, which is a radio transmitter and a very small antenna as a point source, understand that the transmitter inside this meter is operating at a maximum power of what we call 1,000 milliwatts, which is 1 watt, and is operating over a very small amount of time, maybe a few seconds every 2 hours.
Minuscule.
Well, in terms of the time, the duty cycle, it's minuscule. But the fact of the matter is it's very, very low power. And as I increase the distance from the meter, the signal level falls off to the square. So when I double the distance, I lose 4 times the power. When I multiply the distance by 4, my signal strength is 1/16.
Yes.
The other thing we should know is the fact that these meters in the United States, without exception, are mounted in a metal box. And this metal box serves as what we call a Faraday shield, which even absorbs more of this radiation from the house.
Yes, which brings us to my off-the-wall suggestion that if people are really concerned about radio frequency exposure, they can have their contractor put metal screens, copper screens inside their house and stake them to ground. They can get rid of the high voltage lighting and use DC LEDs for lighting inside their home and save a few pennies in the process.
And no more wireless keyboards, no more wireless mouse,
Not inside,
no more
not from
wireless,
not from that room to another room.
television sets. And my understanding, of course, is that with your background, both in the field of physics as well as medicine
A little bit.
and instrumentation, we have to understand that this radio set inside the meter operates in what we call the ISM band. ISM means instrumentation, scientific, and medical, because about 90% of the instruments now used in the hospital are in fact wireless. All
yes.
of your monitoring devices are wireless, and they operate at this ISM band, 902 megahertz frequency band.
That raises an irony. Many hospitals have a sign that says, please turn off your cell phones when you're in the patient area. My understanding is that arose when somebody showed that a patient with an implanted pacemaker could take their cell phone and hold it right next to the pacemaker, and it would disrupt the function of that pacemaker. But if you move it a couple inches away, not a problem anymore.
Well, again, it's the inverse square law.
Of course, exactly.
But
And the people making those signs and doing the administrating didn't have a good understanding of that.
And of course, pacemaker technology has evolved greatly over the last
course,
10 years.
yes.
So
But it's
many
easy.
of these things kind of go back 20 years ago when this technology was.
Well, just as
brand new.
a practical question, this is essentially a small transmitter, is that correct?
You have a small radio transmitter and receiver set inside the communicating smart meter. Yes.
But where's the receiver? In the unit, or
No,
is it elsewhere?
Well, the way this operates, a utility company has a very large geographical range. So the utility company operates what we call a public access communication network that consists of telephone, it consists of broadband, it consists of the internet, it consists of what we call licensed radio. However, we aggregate large numbers of meters in a relatively close location, meaning in, say, a 1 mile radius.
So like a local network.
Well, we won't call it a local network, we'll call it a neighborhood network.
Neighborhood network,
So
fair
this
enough.
means that I could have 500 homes or 1,000 homes in a 1 mile radius operating at this very low power, 902 to 928 megahertz range, communicating to a device which is located on, say, the top of a telephone pole or a light pole, which then takes that data and repackages it and transmits it over a larger, what we call WAN or wide area network. And the objective is to get the data from the meter to the utility company so that the utility company can go about its business of producing bills to invoice the customer once a month, because we no longer are using meter readers as we have for the last 100 years.
Which brings up the question of the whole issue, which also has been raised, of utilities being able to essentially monitor your energy usage, your water usage, or whatever it is on a minute-by-minute, day-by-day basis, and having a whole lot of knowledge about what their consumers are doing on a second-by-second basis. Is there any danger of that information being used in a dangerous way, giving it to the government for whatever reason? Is there any concern on that, privacy concern?
In order to answer that question, we have to kind of dig into exactly what you're saying. If I understand the concern that you've expressed, you're expressing the concern that a third party or a utility company could at any point in time select a particular customer, and by looking at the data coming from that customer's meter, they could determine which pieces of equipment or which appliances that customer is using. The answer to that is no. That cannot be done today with a residential, what we call an inexpensive residential smart meter. The reason for that is that all of the electrical loads inside the home are parallel circuits. So when I combine parallel circuits, I combine 10 100-watt 100-watt light bulbs, or I combine 5 1,000-watt loads,
So
such as frying pans or waffle irons.
The only thing it's going to read is the gross power.
The meter can determine what the gross power of all those loads in parallel is.
But not where it's coming from.
Not where they are individually. However, the spirit and the intent, if you will, of the smart meter was in fact to allow the monitoring of what we call smart appliances. But this requires another set of technologies to be located inside the house, which would allow refrigerators, air conditioning units, dryers, washing machines, dishwashers and the like to actually communicate to a central device in the home, and then communicate with rate structure information from the utility so that these devices can be modulated, meaning turned up or turned down during peak demand periods of time or time of use periods of time to a schedule.
In other words, your washing machine could say, well, no, I don't think we should be washing clothes at 4 o'clock in the afternoon. Let's wait until 2 o'clock in the morning and start the washing machine then.
Yes, that is correct.
Presumably with the consent of the customer.
Right.
But the way that this is done, there's kind of a fork in the road here. And when I initially set forth, and in fact in 2005 in August I filed a great deal of documents with the Public Utility Commission, and here is some testimony that I provided the Commission outlining the structure of an ideal smart meter system. And I made it very clear that the consumer needs to be key. The consumer needs to be the smart person, if you will. The meter is not smart. The meter's job is to simply provide information to the consumer to make the consumer smart. But what has happened is that a number of industries and large companies took this in a different direction, and rather than allow devices inside the home to process the information coming from the meter and in turn communicate with these devices, they would rather see these devices connected via the internet to a large computer located at a third party, what we call a data warehouse or a meter data management company or the utility company, so that the utility company could in fact control your dishwasher or control your refrigerator.
So in other words, what you're talking about is taking control of energy usage away from the consumer and giving it to the utility? or the utility taking away that control?
I have an
in another sense?
analogy.
Okay, well, let me,
Oh, go ahead.
in defense of utility companies, let me say that for the most part, utility companies are the good guys in this entire equation. Utility companies, quite frankly, would just as soon go back to the old days of generating power and billing for it once a month and not worrying about these problems. There is no utility company in the country that has any interest whatsoever in spying on consumers or controlling the consumer's refrigerator. Let's understand the fact that utility companies are in the business of generating electricity and selling electricity and collecting payment for that product. They do a very good job of that.
In the business of turning natural gas into electrons.
And when we have difficulties, as we saw in the hurricane in New York here, the end of last year, utility companies all across the country, including California, PG&E, sent crews to New York to help solve the problem and to help rebuild. Because there's a very strong sense of we got to get the job done and camaraderie, if you will, in the utility industry. So I do not think that we can say that the utility companies are in any ways nefarious.
Can they be co-opted by a nefarious government trying to get information like when is this pot grower turning on its grow lamp or something like that?
Well, a related question is, why do people trust or mistrust our government? And the analogy I was referring to has to do with perspective and values. There is a saying that if you want to help somebody, tell them the truth. And most of us would diplomatically prefer to tell somebody the truth. The other side of that is, if you want to help yourself, tell people what they want to hear. And we've known some very prominent politicians who chose to tell people what they thought they wanted to hear. So it's whom do you trust? I'd say trust the consumer, trust the free markets, and not so much regulators who are given more control than they ought to have. But that's just my voice.
Well, again, when we proposed this technology going back 2001, 2002, and then certainly in 2005, that is exactly what we proposed. What we, in fact, our motto was, we help turn ratepayers into customers.
Perfect.
Because ratepayers are what the public utility commissions in all 50 states call the people who buy the electricity and pay the bill once a month.
Well, thank you very much for the very enlightening explanation of what smart meters are all about. That's all the time we have for this show.